Hello, Year 12. This is Mr. Mumford from his office, stroke his shed. Gonna have a go and try and do a video lesson on these following learning objectives, which is basically all on looking at my book now, page 180, page 181, 12.4 well wave properties 2s, but I'll put that on Edmodo for you. So you know exactly what it is. But anyway, page 180, 181. So you need to know what is meant by superposition. And then you can draw sketch graphs to show two ways superposing each other to produce reinforcement, which is constructive superposition, cancellation, deconstructive superposition. And then you start linking path difference to phase difference and conclude general pattern, constructive and deconstructive superposition using two dippers making ripple tanks in a tank, or making ripples, in a tank, or two sources of microwaves. Now, the microwave is going to be a problem because I'm not here with you to show you the microwaves, but I can show you the ripple tank simulations. We'll have a go with that. Anyway, this is very old software, but it's great stuff. Now, I want to imagine here you've got two waves. You've got a red wave and you've got a blue wave. And these waves, like Cannon Slinky or water waves, they are going along ripples with time. So basically, this is a wave traveling along here from left to the right, and this is a blue wave also traveling left and right. But these two waves, like water waves, can be have superposition or superimpose over top of each other. So if I now merge the two waves together, I'm now putting red over the blue. And you can see now they merge into one because basically, stop it a second, now the red is behind the blue. But what I want to show you now, what happens is the resultant wave. Now, if I take them apart again, which I will do going here, let's separate them. No, can I separate that? That's the one there. Okay, now, and I'll freeze it. So if you imagine that's the amplitude of 1, and that's the amplitude of 1, when the two waves hit each other, then end up being an amplitude of 2, which is up here. But if I got this spot here and that spot there, there's no amplitude there and no amplitude there, so it makes sense there. It's going to be 0. Here, I got -1, and that's -1, and therefore it becomes -2. So what you see is a larger wave. And these can happen in waterways. Have you ever seen the film The Perfect Storm? It's where you've got a poor little fishing boat completely wiped out by a super wave, where two waves meet, make a massive wave, and it sinks the ship. And due to the fact you've got not a lot to do at home at the moment, in the evenings, go and look it up on Netflix or something like that. Look up The Perfect Storm. It shows you that happening in waterways. Anyway, this is called constructive interference. What I mean by that is you've got two waves hitting each other and you make a super wave where the amplitudes are going to be added together. Now, these two waves are in phase. Now, what also can happen is this. And, oh dear, the next one, go across here. If I should work, go on, work, be nice. Nice bit of software. Oh, no, next slide along, I think. It comes up here. Come on, is it going to work? Wishful thinking, give it time, give it time. No, it's died on me. Don't worry. Okay. What I want to do is try and show you, we'll try again, is the one I want to show you is where they are out of phase. So I'll try once more. I said this is very, very old software. Sometimes it works, sometimes it doesn't work. Come on. Page 4. That's the one I want. Oh. We're not doing very well there, are we? I will try the best I can to show you when they're out of phase. Come on, page 3. Next page. Page 4. Come on, software. Oh dear. Okay. Have a go. Have a go. I might have to do it another way. This software is not going to work. It's on the next slide here. I know it is. That's page 3. Can I show you page 4? The one I want is page 4, and it just keeps crashing, doesn't it? Great when things work, not so good when they don't work. I'm going to have one more go, and then I'll give up. And I'll do it another way. Go on, Page 3. Page 4. It worked. Excellent. Right, now, this time you've got two waves. Okay, but we notice the one wave is this one goes up, that one goes down. And when that one goes down, this one goes up. We say they are 180 degrees out of phase. Okay, now, if I now merge these two together like this, okay, and I'll pause it, that one goes up +1 and that one goes down -1. Therefore, if you add a +1 -1, the resultant is 0. There, both ways are 0, so it'll be 0. There, it will be 0. This goes up that little bit there, and that goes down there. Can you still see the resultant wave is 0? Now, in other words, now, if I actually put the two together, I can make it travel, you see a perfect black line. And a perfect black line is basically due to cancellation. The two waves cancel each other out because they're 180 degrees out of phase. And that is basically when the whole wave is cancels out. And I want to show you that because I've got them on here, and that's what's showing here is where you get the big wave coming out. And this one here is when basically when the two waves hit each other, you get a straight line like that. This one, you basically get it going down big and going up big. I'm trying to draw a superb waveform going like this. So this one is a reinforcement and this one is cancellation. Now, where this can happen is coming up with things like this. Now, what I would have done if we're in school is I would have showed you the ripple tank where I have basically water, a dipper going in and out, making these lovely circular wavefronts coming out. And you might notice the two wavefronts start interfering with each other. And you might notice here where you got a dark patch going there, and you see here a lighter grey and a dark patch there and a lighter grey. Now, this is all to do what I've just been explaining. I don't want that one. Close current tab. Whoop. Get back here. Is this one just here, I think it is. Now, this is ripple tank simulation. Now, this showing you, and some of you showed a ripple tank in GCSE, where a dipper's going in and out, creating all these water rays. Okay, you see dark, bright, because basically what these are is the top and the bottom of the wave. So therefore, it doesn't matter which way you look at it. You can look at the bright there as the top of the wave, and the dark as the bottom of the wave. Now, if I then take this to do a two sources, I know it looks well weird, doesn't it? Can you see here where you got that light grey and that dark, light, dark, okay? Now, what is happening here, the waves are traveling out, but they are interfering with each other. And what they create is something called an interference pattern. Now, I'll take that away, and I'm trying to show you how the heck this interference pattern is formed. If we get this nice bit of software to work here. Wow, here we go. Right, now, what you're going to see here is this works. This is now doing it in slow motion. The waves are going out, okay? So here's source 1 and here's source 2. The wave fronts are coming out like this. This is like the peak of the wave, peak of the wave, peak of the wave, peak of the wave. And here again, the peak of the wave is going out. But obviously these two waves interfere. Can you see here, this one goes out and that one goes out. Therefore, here is what we say is we've got reinforcement, because you basically have got the top of the wave meeting the top of the wave, making a super wave. Reinforcement, 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 reinforcement. And you start notice the pattern which you've just seen coming out in that lovely simulation I showed you before. And basically what you've got is the top of the wave meeting the top of the wave like this. Okay, and also we've got one here. Now this is where two waves are in phase and you get reinforcement, and it happens just here as well. Okay, but now what I want to show you is this one, and I'll have a go, put on trough. Now, the dark blue is showing the trough of the wave. Therefore, what I can do now is start showing you cancellation. So just here is where you have got a trough of one source, which is coming from here, meeting the peak of that one. Therefore, you get something called cancellation. Therefore, this is why you start seeing those dark and bright bands coming out. And what I'm doing is I'm clicking on where you've got a peak and a trough meeting each other. We get cancellation. And it's just come out here as well. And you start seeing this pattern, which you saw before in this ripple tank. And what I'm doing is making dots along this line and dots along this line as well. Where here you got cancellation and there you got reinforcement. Cancellation, reinforcement. And what I'm doing is I'm showing you actually, wrong one, and them forming on this nice bit of software here. So what you get is something called an interference pattern. But an important thing I want to show you is here we got cancellation. We say they are going to be, getting hold of my wonderful pen, they are pi out of phase or 180 degrees, which is all the way along here. When you got reinforcement here, they are going to be 0 degrees out of phase, or can be 360, which also can be 2 pi. But also you can look at this in terms of wavelength. You get back what we did before, and a wave going up and down like this. Oh dear, that didn't work out too well. I'll try once more. Draw a beautiful wave going up and down, up and down. That's a sine wave, believe it or not. Where you got naught here, here's going to be your full wavelength, which is going to be here. Here is going to be your half wavelength. And remember, we said before, in fact, getting on a different color pen, let's go for orange. Then that was going to be 2 pi, and that was going to be pi. So therefore, what I'm saying is, if the phase difference comes out pi, basically the phase in 2 ways is pi, you're going to have cancellation. If the phase difference is going to be 0, or it's going to be 2 pi, you're going to get reinforcement. And what I'm trying to do is show you these little wave patterns coming out as well. Now I might show don't want that one. Also a video of this somewhere else. Better quality, I don't know. But I think I'll do it myself here. But these shows you what is happening on your wonderful book, page 180 and 181. And this, the worksheet that I would have put on here, is showing you the phase difference between them. Now, another way, last bit I want to do and show you is you can look at path difference to this. And that's just a tricky bit, but it does work nicely. Now, if I'm going here, and this one is traveling out 1 wavelength, 2 wavelength, 3 wavelength, 4 wavelength, 5 wavelength, 6 wavelengths. This one has gone 1, 2, 3, 4, 5. Now, if that has done 6 wavelengths and that has done 5 wavelengths, the difference, or the path difference, is going to be lambda, which is going to be 6 pi minus 5 pi. When you then have a cancellation or going out between them, like here, this one has gone 1 wavelength, 2 wavelength, 3 wavelength, 4 wavelengths, 4.5. This one has gone 1, 2, 3, 4. Now, the path difference is lambda over 2. It's half a wavelength. So if you get half a wavelength path difference, you get cancellation. Going back to the other one, if you've got a full wavelength, you get reinforcement. And you do need to know what this term is meant by path difference. Anyway, I hope that explained a little bit what it's all about superposition. And I'm going to sign off now, and hopefully I'm going to make a next video all about stationary waves. Bye for now.